Let's see. You know, we're just gonna put that on the back burner for right now. We need it. We need to do something else first. And that's what makes these problems fun, is you get to a certain point, you're going, wait a second, I'm missing information here. I have an equation here, great. I can get it in terms of some other stuff, but still feel like I'm, trying to work out which equations you need in order to solve it. That's the joy. I'm gonna write these down since we'll probably need them again. So XC is equal to 13.263 ohms. That's a C. XL, 16.965 ohms. And I know that VR squared plus VL squared is equal to VC squared. It's also equal to epsilon naught squared. That's equal to I RL times R squared plus I times RL times XL squared is equal to ICXC squared. Since I know R, XL, and XC, I can use this to come up with a relationship between IC and IRL. I can then plug that relationship into here, and I can come out with a relationship between IPS and IC. And it's all gonna just start falling into place. However, I know I plan to finish this and then just take a break, but considering how excited people are right now, why don't we take a break here, let people sort of stretch legs, relax a little bit before they come back and get revved up again. All right. I went ahead and factored RL squared out of this, so you're off to the R squared plus XL squared. Here, went ahead and squared both bits. But ultimately, we're going to end up with this IRL is equal to IC times some number. Because we know XL, we know R, we know XC, and then we need to do a square root at the end. So if someone would be kind enough to actually do the calculations. Anybody have it?
Getting close.
.4149. That's it, you take the square root of it?
You would need to do the square root at the end.
Yeah.
And you took the square root?
Yeah.
Anybody else get the same value?
What was his value?
You said 0.4 something?
0.4149.
What'd you get?
0.5856.
So this would be square root of xc squared over r squared plus xl squared. Do we have a third person?
13.2. R is 15 of those, right?
Did we ever find the value for the angle of IC?
This angle here?
Yeah.
Yeah, because we know this angle here from
Right.
VR to VC.
And then plus 90?
Yeah,
Okay,
and that was the 2 point something
okay.
that I erased.
Do you have your values broken out?
Yeah, but it's the 0.8, or 0.58.
Okay, so you got the same thing he had.
Yeah.
All right, so this is 0.58.
568.
I see. All right, so now we can come back up into here. IVS squared is equal to 0.58568 IC squared plus IC squared minus 2 times 0.5868 IC. 58568 IC times IC times the cosine of 0.72399 or 7240. And so I have an IC squared in every term. So IPS squared is equal to IC squared times 0.58568 squared plus 1 minus 2 times 0.58568 times the cosine of 0.72399.
Yeah, 0.46547.
46547.
Yep.
Any confirmation?
I got the same thing you got.
Okay, all right. So we're getting closer. Now we need to bring in some of the other stuff that we have here, like that information. I know that the voltage from the power supply, maximum voltage from the power supply is the same as the maximum voltage across the capacitor. Because two capacitors are the only two things on each of those paths.
Did we?
Sorry,
Sorry, did we lose our square roots?
should have taken the square root of both sides.
Okay.
So So whatever that is, take the square root, I think you get this.
Mhm.
You got something different?
I got that, but I didn't square root it. The whole thing.
That's true, yeah.
Oh,
It's 0.6822, or 23, sorry,
0.68,
23,
give me another one,
0.68225.
225.
Good catch.
Alright. I assume also, Devon, that you had not square rooted? Okay. I know that using the Ohm's law stuff, the stuff that I erased from over here, the Ohm's law variation of the power supply is that would be the current from the, maximum current from the power supply times the impedance. For the capacitance, that's equal to the current across the capacitance times the capacitive reactance. I can now find the impedance because, well, I have a relationship here between IPS and IC, so looking at this relationship here, I have 0.68225 IC times my impedance is equal to IC times my capacitive reactance, which is over there.
13.263.
IC cancels out, and I now actually have a value, all right, which would be 13.263 divided by 0.68225.
19.4401.
Units?
Well,
Ohms.
Just like the reactance is sort of the resistance equivalent of our analog for capacitance, for capacitors. Inductive reactance, the resistance analog for inductors. Impedance is the resistance analog of the system, the power supply. And so now IPS, looking at this relationship here, because I know epsilon sub naught, that's the maximum voltage, that's the 169.706 volts. IPS is equal to epsilon sub naught over the impedance. So that's 169.704 divided by my impedance of 19.4401. We now have a magnitude of IPS.
I think it's 0.706 on epsilon sub naught.
706?
Yeah.
Okay.
And it's
Then I read 6 over there?
Yeah.
Okay.
8.7297.
Units?
Amps.
So I now have the maximum current that's gonna be coming out of the power supply. I can find IC now because I have a relationship right there. I know that if IC times 0.68225 gives me IPS. So the maximum current coming off the plates or onto the plates would be that divided by that.
$12.7954.
And I can now find the current that's flowing down the middle section, IRL, because I have that relationship right here. 0.58568 times IC gets me IRL.
$7.4940 amps.
All right, I've got all that stuff. I've got a couple more magnitudes I can get easily. I know VR is equal to the current across the resistor, which is IRL, times the resistance. So I have an IRL now times my resistance of 15? Yeah, 15.
112.410.
Volts. And then the voltage, maximum voltage across the inductor is the current across there, which is IRL, times X sub L. And X sub L is 16.965 times the 7.494.
$127.136.
127.136?
Yep.
All right, so let's see what we got. Current across, the maximum current across these, that's the 7.494 amperes. Current from the capacitor, maximum current, 12.7954 amperes. From the power supply, 8.7297 amperes. And I did not write them down, but we'll throw those in here. So we have voltage from the capacitor and the maximum voltage from the EMF, or from the power supply. That's the 169.706 volts. Maximum voltage across the resistor, 112.410 volts. Maximum voltage across the inductor, 127.136 volts. We have all of our magnitudes, just missing a couple of phases here. And this is the wrong. Oh, I know what the problem is, where I wrote this. I wrote phase of the capacitance. There's phase of the voltage for the capacitor and then phase of the current for the capacitor, and I really need to differentiate those. We'll do it when we write the equations. All right, so I've rewritten all this stuff hopefully correctly. All right. The impedance has done its job. That's done its job. And I've rewritten those. Okay. The voltage from the power supply, 169.706 volts times the cosine of, and instead of just writing omega over, this number over and over again, I'm just gonna write omega. Capacitor, same. Voltage from the resistor, and I have erased things that I didn't want to. Oh no, there they are up there. Maximum voltage across the resistor, that's the 112.410 volts times the cosine of omega t, and now for the phase shift. We've already done the hard part, now it's figuring out plus or minus what angle. I'm looking at the angle between what I've established as 0, so voltage from the power supply, and the voltage from the resistor, which is down here. What is that angle?
-5.1.
Yeah, it's the negative of that. Minus 0.84679. Voltage for the inductor, we have our maximum value of 127.136 volts times the cosine of omega t. And then what's my angle here?
2.
So plus 0.72400. So got 3 equations there for voltage. Now let's go for the currents. So current from the, let's go across the resistor. My maximum current across the resistor, 7.4940 amperes times the cosine of omega t. What's the phase?
Just trying to find the,
This was IRL.
oh, that's right. So, negative, 5.1 again?
Yep, 0.84679. Current for the inductor,
Wait, is this in relation to the current of the power supply, or the,
the voltage of the power supply.
okay, yeah,
IL and IR are the same thing, because if they're on the same strand, they're in series. IC is, my maximum value is 12.7954 amperes times the cosine of omega t
plus pi over 2.
plus 1.57 something. You know what pi over t works. And now the power supply. My maximum value, we got, that's the 8.7 amperes times the cosine of omega t. And again, I want this angle right here between the power supply and epsilon sub naught. I have power supply and V and, oh, did I? Oh, I never found that angle.
Nope.
So let's do it. This is the angle between the power supply and IRL, so that's between this and the horizontal.